Question 7 is coming from functions. Functions f and g are defined as follows. F of x is here, which is valid for x less than or equal to -1. And then g is a straight line, which is defined for x greater than or equal to -1. Part A, express f of x in this format, and then state the range. There are two ways we can do this one here. Pick the one that is simpler for you. So we have, if our f of x is equivalent to x squared plus 2x plus 3, the coefficient of x squared is already 1. So I got the coefficient of x, I divide it by 2. If the coefficient of x here is not 1, we first factorize it, okay? Now, we are going to get this one, we divide it by 2, you will get a 1. Why do we divide by 2? We have this expansion here. If I have x, let's say plus a, then squared, this one is going to be equal to x squared, then plus 2ax, then plus b. You see that? Sorry, it's not b, it's a squared. So if I take this one this side, that means I will have x plus a squared minus a squared, which is equal to x squared plus 2ax. So this side, I only wanted the expressions that are having x. Now, if you can look inside here, you can easily see that the a which is here is this 2a divided by 2. You see that? So this one, when you divide it by 2, you will get the a here. And then this a is popped out here and squared. You see that? So that is what we are going to have here. We shall say this one divided by 2, you will get a 1. So that will be x plus 1, then bracket squared. We pop this out here, and then we put that 1 squared, then plus the 3. So this one is going to be x plus 1 squared, and then 3 minus 1, that one will give us a positive 2. So plus 2. That is it. So our f of x is that. It is already in this format where a is a 1 and b is a 2. Okay, so that is that. Alternatively, we can expand and equate coefficients, okay? Alternatively, we have x squared plus 2x plus 3 will be the same as x plus a squared then plus b. So we expand this one, it will be x squared plus 2ax then plus a squared, then plus this b here. So we equate the coefficients of x squared, the coefficient of x, and then the constant term. So already the coefficient here is a 1, okay? And then here we have 2, so we equate to this one here. So meaning 2 here is going to be equal to 2a. Now we can divide all through by a, and then by 2, then our a becomes a 1. You see that? Then the constant term here is a 3, then is equal to the constant part here, which is a squared, and our a is 1, then plus the b. So take this one here, it will be a minus. So 3 minus 1, then b becomes a 2. Now, we conclude and we say that f of x is therefore going to be x, then plus the a we have gotten is a 1, and then the b we have gotten is a 2. As simple as that. So pick the method that is simpler for you. Now, we need to find the range of f. Now, when we look at f of x here, the coefficient of x squared is positive. That means this one is a U-shaped curve. Okay? It's a U-shaped curve. And the turning point, we get this one and we equate it to 0. So x is going to be -1. And then this one will be a 2. So the turning point is this one here. That means all the values of f of x, all the values of y are bigger than these 2. Okay? Because it is rising up this way and also this way. You see that? So meaning this is the minimum value. So the curve has a minimum point. So we are going to have f of x. The range is going to be range of f. By the way, the range is supposed to be written in terms of the function. The domain is written in terms of the independent variable, for example, x. Okay. Now, what we are going to have here, the range is going to be f of x is greater or equal to the 2 that we are having here. Now, sometimes I want you to look at the domain that is given here, less than or equal to -1. So they are choosing this such that this curve can be a 1-to-1. We can choose the left of the turning point or the right of the turning point. If they leave it open that x is real, okay, all values, that means this one won't have a turning point. Why? Because all these values, we can get 2 x values here, the one here, and then another one here, giving to the same y value here. Do you see that? So that is many to 1. So this one cannot have an inverse. The one that has an inverse is going to be, they choose either this other side or this other side. Now, here they have chosen the left side of the turning point this way. They can pick a figure from this way. If this is -1, they can pick -2 or -3. That means the range you're going to have is not going to be this one. So you have to get the value. Let's say it is -2. Now, you are supposed to get the value of f when you put -2. So it is going to be a value there. That means now you are going to start from that value to go that other side. So the range will change here. Okay, so you have to always look at the x coordinate that is given in that case. All right, so when you actually look at this one here, the x coordinate they gave is actually the one that we have in the turning point. So we have to start from there already. So what is the value of f when we put -1? It is already 2. So we begin from the 2 and then above. I hope I've made everything clear. Then part B, find an expression for the inverse. I'll say let my inverse be equal to y. So meaning x is going to be equal to f of y. Now, when they give you the quadratic equation, you are supposed to express it in the completed square format. So if you don't do that, there is no way you are going to make x the subject of the formula here. Okay, so we are going to have this one that we got. It is the one that we are supposed to use. So x plus 1, then bracket squared plus 2. So where there is x, I'm going to put y. That is interchanging x and y. So it will be, remember it is x plus 1, so it will be y plus 1 squared, then plus 2. Now make y the subject of the formula. Bring this one this side. We shall have x minus 2. And then this one is equal to y plus 1 squared. Take the square root on both sides. Of course, you will have plus or minus. That is x minus 2. And then this one will be equivalent to y plus 1. Now take the one this side. This simply implies that we shall have a -1 here. Then plus or minus the square root of x minus 2. Then this one will be equal to y. Now, the inverse function here is therefore going to be equal to -1, then the square root of x minus 2. If you put plus or minus here, you are going to get your answer wrong, because a function has gotten an inverse if it is 1-to-1. So we are supposed to choose one of these two signs, either plus or minus. But then how do you know that this is the sign you're supposed to choose? In the previous videos, I've always told you, just look at the domain. Look at the domain of f. The domain here, okay, is x less than or equal to -1. Have they chosen the side which is the left of the turning point? Then choose the minus. Have they chosen a side which is right of the turning point? then choose the positive. Let me show you why you are supposed to do it that way. Now, when I come here, remember we have the domain. If these are the x values, this one is going to be the domain, and then this one is going to be the range. Okay, so if f acts on x, what comes out is the f of x, right? That's the range. And then what takes this one back here, what undoes what the function has done is the inverse, right? So what you put in the function is always the domain. So the range of f is actually the domain of the inverse. So this will be the domain. The domain of this inverse is the range of the f. All right. Then here we are going to have the range of this inverse. Now we have our f of x, which is equal to, we have x plus 1 bracket square, then plus 2. Now we are going to choose a value of x that is, let us choose a value of x. We are not going to choose that -1, okay? Let's choose, since they are taking values less than or equal to -1, so let us choose a value this way. Let's take -2, okay? So when I take -2, if x is equal to -2, and then I put it in here, we shall get -2 plus 1, that will be a -1. When you square it, it becomes a 1, then plus 2, that one will give us a 3, okay? Now, when we go to the inverse, because the value you have gotten here, the range of f, is now going to be the domain of the inverse. So this value that I've gotten here, I'm supposed to put it in the inverse. So the inverse function is here. When I put it in there, do I get back this -2 when I use the plus or when I use the minus? So f inverse of 3 is going to be equal to -1. Then there is a square root here, so 3 minus 2. Of course, 3 minus 2 will give you a 1, right? Square root of a 1 is a 1. So we have -1, and then here we have a 1. Now, for us to get this -2, do you think we shall put a plus here or we shall put a minus? When you put a plus, automatically this one is going to give you 0. It is not giving you -2. So we are therefore going to put a negative. So this one will give us now a -2. Do you see that? So therefore the sign that I'm supposed to put here is a minus. But remember that when you come back here, the domain is taking the left side. The domain is on the left side of the turning point, the left side. So when you see they are taking the left side of that turning point, take the minus sign. If it were greater or maybe greater than or equal, they are taking the right side, then take the plus. As simple as that. You don't need to do all that I've done. I was just proving the point here that if they are choosing the left, then you choose the minus. So for you, when you reach here, just look at the domain. Were they taking the less than or the less than or equal? Take the minus. Greater or greater than or equal? Take the plus. Part C, solve the equation gf of x is equal to 13. Now, gf of x, we are going to have our f of x is x squared plus 2x plus 3, which is equal to 13, okay? Or we can use the completed square format, whichever you want. So g of x was actually given as 2x plus 1. So wherever there is x, we are going to substitute it with the f of x. So 2x plus 1. I'll have 2, then the x, I replace it with the whole of this, then plus a 1, then this one will be 13. Take the 1 here, that will be a 12, okay? Then x squared plus 2x plus 3. There are many ways to solve this. You can open the brackets here, but I would like to divide all through by 2 to simplify this. So this one will be a 6. Now when it comes to this side, we shall have 3 minus 6 that will give us 3 minus 6, that will be minus 3, right? This is a quadratic equation which we can solve. Two numbers, when I multiply them, they give me negative 3, but when I add them, they give me 2. That will be a positive 3, okay? And then a negative 1. When you add these two, they give you the 2 here. When you multiply them, they give you the negative 3. So we shall have x plus 3 and then x minus 1, which is equal to 0. So meaning when I equate these factors, we shall be in position to get x is equal to negative 3 and then x is equal to negative 1. Positive 1. We can see that the range of f, remember, is going to be put into the G. The range of f is this one here, greater or equal to 2. These are positive values, greater or equal to 2. But then the domain here is greater or equal to negative 1 for G. Okay. Now we are going to get 1. We are going to take 1 because when you look at f is valid for the x values that are less than negative 1, that are giving you these values. You get it? So we shall take negative 1 because less than or equal to negative 1, we have the negative 2, negative 3. That is where the x values were chosen for the f. Okay, so our answer here is going to be equal to negative 3. Okay, it is the one that is in the region of the domain of f was x less than or equal to negative 1. So from those values, that is where we get the range of f being f greater than or equal to the 2. So that is that.